Nice. Alright guys, how's it going? So for this last video I will do a problem and it's going to be based on energy. So it's going to be the energy portion of physics. So here's the problem. So we have Bob and let's say he uses a slingshot to throw up a 20-gram pebble. So here's the pebble. This is 20 grams. Up into the air with a speed of 25 meters per second. The question is, how high does it go? So, pretty simple. You have the pebble, which is 20 grams, and then the speed at where he slingshot it is 25 meters per second. So we just want to find out how high it gets. Or just say x, and x final, whatever. So, we finally write what's called the energy formula, which is essentially the kinetic energy initially plus the potential energy initial is equal to the kinetic energy final plus the potential energy final. So what the hell is this? So essentially we have to look at this problem at two different sets of time. The time before he throws the pebble, and then the time after the pebble's been in the air with the speed. So we can easily just break this down now. Well, actually, before we do that, now I'm actually going to do that. So before we do that, we say, okay, so initially, we know that the pebble's not moving and there's no speed. But once it gets up in the air, then we know, oh, there is some speed now, and there is some, like the mass maybe plays an effect or something. So you're wondering, well, how the hell is this going to help us solve this equation? Well, this alone won't. These are just representations of their actual formulas. So the formula for kinetic energy, I'm sure you guys know this, but I'll just write it down for you guys to remember. Is actually half mv squared. So this is basically the formula for kinetic energy. Kinetic energy is just something that's already been up in the air and it's using some sort of power to what's it called? Sorry, it's been a sorry. It's yeah. I feel so bad. I'm sorry. It's weird. Like there's some concepts that I cannot explain it well, but I can, when I see it, I'm like, oh, I get it or something. So yeah, so essentially kinetic energy is just, I guess they call it energy that's being used, and then the U. Well, this one I could explain. This is just mgh. This is essentially energy that's being stored at a certain point that's like essentially ready to be used whenever it falls down. You can call this basically as almost as getting ready energy or something. That's the way I used to say, just getting ready. Like it's about to be used, but it's just not used, just being stored. So with this, going back to this equation, they call it gravitational potential and this is called kinetic energy. It's weird. So with this, we can rewrite this as half mv squared plus mgh is equal to half mv squared plus mgh. We might think, well, wait, can they just cancel out and it's zero? Well, this is where the I and the F comes in. So this is basically assuming this is initially and this is final. So if we know that so if we know that initial velocity is zero, because again, when it goes up, it has no speed initially. You know that this will go to zero. But this has a speed, so we leave that alone. And then, but if we also know that what do they call? I'm sorry. Yeah. Oh, okay. So, but if we also know that once it gets to a certain point, it would be zero, then this would be zero. So essentially all we have left is this. So we have m half mv squared, the final, this is when it's already in the air, is equal to the potential energy to where it starts. The reason is because we want to find out what initially is the height after a certain point. So we want to find out this h, the height. Well, you can say, well, we know gravity, that's 9.01, that's standard. We can actually cancel the masses out because it's the same mass. We know what v squared is, and then half. And actually that's it, yeah, that's all you do. So h then is just essentially equal to v squared over that's a really bad 2, over 2g. So then, yeah, so then the v is just 25 meters per second. Once you solve that, your h just becomes a simple 32 meters. So in the end, we didn't really need the mass of the grams because they canceled out. And yeah, this is actually a pretty simple problem actually. So this one was alright. It was alright. So I mean, so this one, at least hopefully this was probably the easiest one out of the ones I've done today. And yeah, so I hope you guys enjoyed today. I probably won't do this again, but you know, for a future. But you know, hopefully you guys were able to understand what I was able to do, and hopefully you guys enjoyed it. So that's it for today's High Miss Physics, and I hope you guys enjoyed it. And I'll see you guys tomorrow with a new set of videos. Thank you, and have a good rest of your Wednesday.